All right, so now we're going to apply this significant figure things to multiplication. And multiplication has a little bit of a different rules, actually a lot of bit of a different rules than addition and subtraction. Basically, math rule number 3 is the only one that really applies to, well, not the only one, but it's the one that mostly applies to the product and quotient rules, is the product and quotient of a measured data cannot have more SDs than the quantity with the fewest SDs. Here's what it means. So I measure out an area of a piece of paper, and in order to do that, I got the length and the width. So apparently the length is 11.5 and the width is 5.5 centimeters, both centimeters. So in this case, the area is equal to length times width, and if I plug that into my calculator, I get 11.5 centimeters and 5.5 centimeters. Now, when I plug it into my calculator, the calculator spits out 63.25 centimeters. But the question is, how many significant figures did I have to begin with? Well, this number right here had 3 sig figs, whereas this number right here had 2 sig figs. So my answer can only have the the precision, the number of sig figs that my answer can only have the same as the number of sig figs that the lowest measurement can have, and that would be, when I'm doing multiplication and division, that would only be 2 sig figs in this case. So I need to round it off up to this point over here, so then my 63.25 is actually just 63 centimeters as what I would report. I'm sorry, and it would actually be centimeters squared, because I multiplied the units of centimeters, and I got centimeters squared. That brings me to another point. I think that if I go up screen right here, when rule number 1 said that the measured data must have the same kind of dimensions and the same units before they can add and subtract, that's not true with multiplication and division. They just need to, you can multiply 2 different units together and get a completely different unit, or a third kind of unit after that. Like, for example, if I wanted to find the volume of this thing, I would multiply, say that this wasn't a sheet of paper, but this was like a stack of papers. I would get the height of that thing, and I would multiply this 63 centimeters squared by some other number, let's say 5 centimeters. And my answer would end up being something centimeter cubed. And actually, I wasn't ready to do this in my head, but why don't we try it? Let's see, 6 times 5, that would be 300, and then an extra 3, so that would be 15, so it would be 315 centimeter cubed. And here's the thing, is how many sig figs do I report now? Well, this number right here only has 1 sig fig. So what you would do is you would round this off to say, okay, well, this is equal to 300 centimeter cubed, because I need to bring this thing down to its lowest amount of sig figs, and in this case it would be just 300. Maybe if I want to be more precise, I should actually say, well, I measured it to be 5.0 centimeters. Even if I put 5.00 centimeters, say I had some kind of super good ruler to measure this would have 3 sig figs, but my answer can only have 2 sig figs, because this thing over here had 2 sig figs, and I'm multiplying them together. So in that case, if I told you that the height of the thing was 5.00 centimeters, then my answer would be 320 centimeters cubed. There are, sometimes we multiply things and we keep the same number of sig figs as, well, I guess sometimes we multiply things by precise numbers. And so that would bring us to rule number 4. And I don't really have an example pulled up for this, but I mean, I'll explain it to you. The product and quotient of a measurement, or some kind of counted number, or conversion factor, or defined value, has the same number of decimal places, same precision as the original measurement. And here's basically what it's saying. I don't know if I always was taught that it has the same as the original, but I always was always taught that it has infinite. So for example, if you measured the mass of an egg, and I don't have no idea what the mass of an egg is off the top of my head, let's say it's 10.37 grams. All right, I'm just making that number up. I have no idea whether that's even close to what an egg weighs and whatnot, but let's say 10.37 grams. And you have a dozen eggs, so you times it by 12. How many eggs do you have, or how much, what mass of eggs do you have in the end? Well, that would be, let's see, I don't know how to do that off the top of my head, so I'm just gonna plug that into my handy dandy calculator. 10.37 times 12 is equal to 124.44 124.44 grams. Now the question is, where do we round this number off to? You see, this number over here has 4 sig figs, whereas this number over here you would think has 2 sig figs. But the thing about it is, this number right here is not a measurement. I didn't measure 12. I just counted out 12. I know that there are precisely 12. So this number right here shouldn't affect the number of sig figs I want to report, because that is a counted number. That is a ultimate precision number. I actually say this thing has, I don't know, 20 sig figs or 200 sig figs. The number of sig figs that it has adjusts to whatever, how many sig figs you have here, because you don't want this number cutting your answer down. So I guess the way that their rule is set up, you can say that this is exactly 12.00 because that has 4 sig figs, and then I would have my answer be, report my answer as not 124.44, but rather 124.4 grams, because I would cut it down to 4 sig figs. And ultimately, that's governed by this number right here. So when I said that this 12 can have 20 sig figs, it doesn't really matter, because whether it had 5 sig figs or 500 sig figs, this number right here would be the one that cuts the number down. So that's kind of what's going on. And as we get through this, you're going to find that some numbers are counted numbers or precise measurements and those kinds of things. And those shouldn't limit your significant figures. The other thing I wanted to do was talk to you about if I were to do this calculation, this one up here, and this is math rule number 5. I'm not going to write it down. I'm just going to read it off to you. Math rule number 5 says, in a compound calculation, do not round off intermediate steps. You see this step right here where we wanted to find, let's say instead of finding the area, we wanted to find the volume. And so we have volume is equal to length times width times height. And so what we did was we multiplied the length times width and we got the area, and then after that we multiplied it by height. What I would do is I wouldn't round off this 63.25 over here and make it 63. I would multiply, I would just keep all of my numbers, 63.25, and then multiply that by 5.00 centimeters, and then get my answer. And then at the very end, you say, well, okay, how many sig figs did I have? The first one was 3, the second one was only 2. My pen's not working anymore. What's going on? And so, you know, and then the last one is 5, and that's how you do it. All right, cool. I hope that works.